There's this really weird thing happening at the heart of modern AI that just doesn't quite add up. On one hand, we're seeing AI models do these incredible things. I mean, they're passing the bar exam, they can diagnose really complex medical issues, they write sophisticated code. But then you ask these same brilliant systems to do something that seems ridiculously simple, like just add 15 numbers together correctly, or follow the same basic instruction over and over, and they just fall apart.
So what is going on here? Why are these incredibly powerful models breaking down on tasks that should be easy, as long as they're repetitive? This isn't just some funny little quirk. It's a huge, fundamental challenge for AI researchers. And, as we're about to see, the answer is really not what you'd expect. All right, so to get to the bottom of this, researchers set up this really clever experiment to figure out the exact point of failure, which brought them to what they're now calling the AI execution paradox. They started with this key idea. Pretty much any task has two parts, right? First, there's the planning, figuring out what you need to do. And then there's the execution, the part where you actually do it. So they thought, hey, what if the problem isn't the AI's ability to reason or plan? What if it's just its ability to follow through, step after step after step? The experiment they designed was just brilliant in its simplicity. They gave the AI all the knowledge it could possibly need, basically a dictionary of words and their number values. Then they gave it the plan, a specific word to look up. So all the AI had to do was execute, find the number for that word, and add it to a running total. This completely stripped away any complex thinking, forcing the model to focus on just one thing: relentless, repetitive execution. And this simple little test, it led them to their first huge clue. It was a completely counterintuitive discovery that kind of flips the script on how we think about AI progress. So you'd probably think that AI progress follows the law of diminishing returns, right? That the improvements would get smaller and smaller over time. But for these long, drawn-out tasks, it's the exact opposite. It turns out that even a teeny tiny improvement in a model's ability to do a single step correctly doesn't just make it a little bit better, it makes it exponentially better at completing a long chain of those steps. I mean, just look at this data. It's wild. An AI that's 80% accurate on a single step can only get through about 3 of them before it fails. Get it to 90% accuracy, and it makes it 6 steps. Okay, but now look at this. Jump from 90 to 99% accuracy, and it suddenly completes almost 70 steps. The performance doesn't just increase, it absolutely explodes. But wait a minute, that just makes the mystery even deeper. If these small improvements give you such massive gains in endurance, why are we still seeing even the best models fail so quickly on these simple, long tasks? Well, this leads us to the real culprit behind all these failures. This hunt for the true cause led researchers to the core of the whole problem, a subtle but totally devastating flaw that they call self-conditioning. You see, it turns out our basic assumption about how these things fail was wrong. A model doesn't just have a fixed, steady chance of making a mistake. It's not like a factory machine with a constant 1% error rate. No, an AI is different. Its chance of messing up actually goes up the longer it works on a task. And this is what they call the self-conditioning effect. Essentially, the model is learning from its own output as it goes. So when it makes a mistake, and that mistake becomes part of the conversation history, the model sees that error and becomes conditioned to be less reliable. It's a true downward spiral, where one error makes future errors even more likely. Now, this is the complete opposite of how we humans learn, right? When we make a mistake, we get feedback, we correct ourselves, and hopefully we improve. But for a language model, that feedback loop actually reinforces the bad behavior. An error in its past doesn't teach it how to succeed, it teaches it how to fail again. So this self-conditioning thing creates that nasty downward spiral of errors. And here's the kicker, it's not just about the model running out of memory or context. Researchers proved this by taking a perfectly good model and just injecting some fake errors into its history. And just like they predicted, its performance in the future completely collapsed. Even just building bigger and bigger models doesn't seem to solve this fundamental problem. But, and this is a really big but, there is a solution, and it's a fascinating one. It's all about getting the models to do something we might as well just call thinking. A standard model gets totally trapped in that self-conditioning loop.
It sees its past screw-ups and just continues that pattern of failure. But a thinking model, one that's been trained to generate its own reasoning before it gives an answer, it can break free. It basically learns to ignore its own flawed history and stay focused on the task at hand. The secret sauce here is that this thinking process forces the model to come at the problem fresh every single time. Instead of just trying to continue a conversation that might already be full of mistakes, it reevaluates the task at each and every step. And that makes it immune to the poison of its own past failures. And the jump in performance is just staggering. We're talking more than 100 times better. A model trained to think, like DeepSeek R1, can execute over 200 steps in one go. You take that same model, but without the thinking part, it fails after just 2 steps. 2. And now we're seeing this massive performance gap opening up between different models. You've got thinking models like Claude 4 Sonnet pushing past 400 steps, and now there are projections that the upcoming GPT-5, codenamed Horizon, might be able to execute over 1,000 consecutive steps without a mistake. This really defines the new frontier, the new battleground in AI development. Building this kind of endurance, what the researchers call long horizon execution, is where the most advanced proprietary models now have a huge leg up on their open source competition. So, if we pull back, the key thing to remember is that this AI failure on long tasks isn't a reasoning problem, it's an execution problem. The real bad guy is that self-conditioning effect, where errors just create more errors. But the breakthrough, the hero of the story, is that these thinking models can smash that cycle, unlocking incredible gains in reliability. It really tells us that the future of AI isn't just about what it knows, but how long it can actually stay on task. This really shifts the entire conversation, doesn't it? The next big race in AI isn't just about raw intelligence or who has more knowledge. It's about practical endurance. And it really makes you wonder, what becomes possible? What will we build when we can create AI agents that don't just start a task, but can actually be trusted to finish it?